Solving systems by elimination. So we have systems of equations. Our first one is a 3x plus 2y equals 1. Our other equation would be x minus 5y equals 6. Now, if you notice, there are no additive inverses because additive inverses will cancel each other out. So that's a 3x and that's a 1x, and that's a positive 2y and it's a negative 5y. So none of these have additive inverses. Now, I can get additive inverses if I use multiples. So if this were a 10y and this were a negative 10y, then I have additive inverses. Now, how I chose 10 is because 10 is a multiple of 2 and 5. Okay, so let's use 10 to get our additive inverses. So this needs to be multiplied by 5, and this will become a 10. So let's multiply by 5. To get this to become a 10, or negative 10, shall I say, I need to multiply this by 2. So we'll multiply that by 2. Okay. So as a result, this top line, if we distribute our 5, will become 15x plus 10y equals 5. Now, if I distribute my 2 to each of these, this will become a 2x, a minus 10y, and a 12. Now we have additive inverses of 10y and a negative 10y. So additive inverses, when we have them, we can combine both equations. 17x becomes 0 equals 17. And allows us to solve for one of the variables. So we get 17x equals 17. I'm going to divide both sides by 17 to get the x by itself. And as a result, we get 1x equals 1. Or just x equals 1. Now, given that we know that x equals 1, we can go back to one of these two equations. I'm going to choose the 3x plus 2y equals 1. Okay, let's stop there and say 3x plus 2y equals 1. I'll replace the x with a 1. So this becomes 3 times 1 plus 2y equals 1. 3 times 1 is 3 plus 2y equals 1. And I want to subtract 3 from both sides to solve for the y here. And what I end up with is a 2y equals negative 2. And if I divide both sides by 2, we will end up with y equals negative 1. So those are our two solutions. X is 1 and y is negative 1. Now for my second equation, we have a 3x minus 2y equals 14. And our second equation is a 2x minus 5y equals 13. Now, once again, we have no additive inverses. This is a 3x, that's a 2x. This is a negative 2y, that's a positive 5y. So there are no additive inverses around. I can make my own additive inverses by finding the least common multiples. The least common multiple for the y's would again be 10 because I have a 2 here and a 5 there. But I need one to be positive, the other one to be negative. So I'll make this the I'll make that the negative 10 and I'll make that the positive 10. So to make this a negative 10, I have to multiply by 5 because 5 times negative 2 will give us negative 10. For this to be a positive 10, I got to multiply by a negative 2. So we're going to multiply by negative 2. And that will give us a positive 10. And thus additive inverses. So 5 times 3, x is 15x. 5 times the negative 2y is negative 10y. And 5 times the 14 will give us 70. Okay, multiplying by negative 2, we're going to get negative 4x. Negative 5 times negative 2 will give us positive 10y. And negative 2 times 13 will give us negative 26. Okay, great. And so here are our additive inverses. Negative 10y, positive 10y. So now we can combine those two. Or combine everything. So I combine this, I'm going to get 11x. These go away. And 70 minus 26, that's going to be 4. And let's see here, 6, 4. Okay. And then I'll divide everything by 11 here. And I will get x equals 4. All right. Now that we know that x is 4, we can go back and choose one of the two equations. I'll choose this one right here, which is the 3x minus 2y equals 14. And now we're going to substitute 4 for x. We get 3 times 4 minus 2y equals 14. 3 times 4 will give us 12 minus 2y equals 14. And now continue to solve for y. We're going to eliminate the positive 12 using a negative 12. And we will end up with a negative 2y equals 2. And now we'll divide both sides by a negative 2 in order to get a 1y. So negative 2 and then negative 2. And we end up with y. 1y equals negative 1. And so those are our two solutions. X is 4 and y is negative 1.